Alright, today we will be multiplying and dividing powers of 10. So, the first problem we have is 5 and 47/100 times 10 to the 4th power. Now, we need to use our prior knowledge and build upon our prior knowledge of place value. So, we have 5 and 47/100. Notice the place value I have before you is ones, tens, hundreds, thousands, 10,000s, 100,000, and millions. But I have decimal, so I have 4 tenths, and I have hundreds, 7 hundreds. All right, so I have 5 ones and 47 hundreds. All right, let's look and build on our concept of multiplying by powers of 10. All right, remember that as I go to the left, all right, so we're building on our prior knowledge of place value when we multiply and divide by powers of 10. So we have 5 and 47 hundredths. Now, let's look at where the digits shift in our number, okay? And where the decimal is moving, all right? So, notice that we go to the left with the digit to the left is 10 times as much as the digit to the right, all right? So, the 5 is in the ones place. So I want to go 10 times as much 4 times. All right. So 1, 2, 3, 4. Wow. Awesome. Building that concept. The digit always shift to the left because we want to go 10 times as much. So the 4 in the tenths place. Watch how the digit shift from tenths to ones to tens to hundreds, hundreds to thousands. Now, let's look at how the digit in the hundreds place shift. Well, it shifts from the hundreds to the tenths, okay, to the ones, to the tens, to the hundreds. Now, what do we put here? Our placeholders are zeros. So, when we multiply by 10 to the power of 4, we go to the place value that's 10 times as much 4 times. Another way to write this is 5 and 4700, okay, times 10 times 10 times 10, okay, which is 5 and 4700 times 10,000. And notice what place value column we ended up in, our 10,000. So it's a lot of depthness in this problem. The exponents is a good indicator for how many times to multiply the base. And you can use the exponent to, instead of writing just a multiplication sentence for 10 times 10 times 10, you can also write 10,000. Notice that the exponent, okay, you should have the exponent also is the same as the number of zeros. So that's something else that you can take from this problem. And notice that the digit that once was in the ones place should end up in the 10,000s place based on 10 to the power of 4. So the digits shift to the left because as you go further to the left, it's 10 times as much. Each digit to the left is 10 times as much as the digit to the right. Now, let's take a look at what our decimal is doing. Our decimal was first in between the 5 and the 4. Okay? Then it moved in between the 4 and the 7. So that's 1. Then it moved after the 7. That's 2. All right, then it moved again. We needed a placeholder here. All right, then it moved again. So we ended up having 2 placeholders, which we use zeros. So our final answer, the decimal is no longer in between the 5 and the 4. It is now behind the second 0, or simply put 54,700. So this place value chart helps build the concept that the digits move to the left, all right? And each place value to the left is 10 times as much as the place value on our right. All right, let's build our concept with the second problem, 2 and 3600ths times 10 to the second power. All right, so we have hundreds, so we have to include the tenths and the hundredths place because we have 2 and 36 hundredths. So we have 2 and 36 hundredths.
Wait.
All right, so we have 2 and 36 hundredths divided by 10 to the second power. Now, let's use our place value chart and write that. So we have 2 ones, 36 hundredths. All right, now the division, operation division symbol lets us know that 2 and 36 hundredths should be decreasing by 10 to the power of 2, or 10 squared. All right, so let's see what that looks like. If we're dividing, then it's decreasing by 1/10. Okay, so the 2, so 1/10 of 2 ones. All right, so 1/10 of 2 is 2/10. Okay, 1/10 of 2 is 2/10. Okay, but I want to decrease by hundredths because 10 squared is 100. So I need to go to the next place value. All right, 1/10 of 2/10 is 2 hundredths. Okay, notice that as I go to the right, my number that I started with gets smaller and smaller, and the digits shift more to the right. So 1/10 of 3/10 is 3 hundredths. Okay, 1/10 of 3 hundredths is 3 thousandths. Okay, let's look at the digit in the hundredths place. 6 hundredths. Well, 1/10 of 600, okay, is 6,000. Okay, 1/10 of 1,000ths is, so 1/10 of 6,000ths is 60 thousandths. Okay, notice that we have an empty space here, which we will put a 0 as our placeholder. So we have 236 10,000ths. Okay, now let's look and see what happened. The digits shifted to the right, which lets us know that's correct based on our operation of dividing. The number gets smaller and smaller. And it got smaller 10 squared, okay, by 10 squared, or hundredths. 2 and 36 hundredths divided by 100 is no different than saying 2 and 36 hundredths or 2 and 36 divided by 100. All right. So notice that my digits shifted to the right, but my decimal is doing something. Watch this. It started out in between the 2 and the 3. All right. Then it ended in front of the 2. Then it ended up where I needed a placeholder and a 0. So my decimal now is in front of the 0. So my final answer is 236 10,000s. So as the digits shift to the right, the decimal was actually moving to the left. That's why we can simply solve these problems quickly by taking the dividend and simply moving 2 places to the left based on our exponent. Okay, here we can do this instantly and quickly once you got the concept built. Okay, by simply moving the decimal to the right the same amount of times our exponent. 1, 2, 3, 4. All right, that's why someone can take these problems and solve them very quickly. Because once the concept is built, where the digits shift and where the decimal moves, then we know we can answer by simply moving the decimal and just understanding which way the digits should be shifting. I hope that helped.